Now we will move on to descriptive statistics and data graphs. There are two main types of statistical data they are called qualitative and quantitative. Qualitative data is data that is classified by type, such as the different species in a forest within your study area. Quantitative data is numeric and can only be represented by a number, like the number of specific tree species in your study area. Breaking data types down further, there are 4 different levels. Nominal or categorical data is the lowest level because you can do the least amount of analyses with it. It contains categories such as tree or bird species and does not have an order or direction. Ordinal data is ranked data, but the measurement between the values is irrelevant. This includes things like low, middle, and high income levels or Likert scale data, which I'm sure you've all seen on numerous surveys that ask you to decide between some level between how much you agree or disagree with a statement. Interval data is data where the differences in the measurement do matter, but there is no true zero value, such as temperature measured in degrees Fahrenheit or Celsius. Ratio data also requires the differences in measurement to matter, but does have a true value of 0, like degrees Kelvin. In ArcGIS, you can pull up a table that has most of the descriptive statistics. Knowing the min, max, median, mean, and standard deviation values are crucial to analysis. Standard deviation measures the amount of variation or dispersion in a dataset. A low standard deviation indicates that the value tends to be close to the mean, while a high standard deviation indicates that the values are more spread out over a wider range. Skewness is a measure of symmetry, or more precisely, the lack of symmetry. A distribution or data set is symmetric if it looks the same from left to right in the center point. The skewness value of a normal distribution is 0. Kurtosis is a measure of whether the data is heavy or light-tailed relative to a normal distribution. Data with higher kurtosis tends to have heavy tails or more outliers. Data sets with lower kurtosis tend to have light tails or a lack of outliers. When creating a graph to display your data, you need to determine which bins you will use. Bins are the way you group the values in your data set. Depending on your data and the information you want to convey, you will choose a bar graph, histogram, line graph, or pie chart. Bar charts can be used with qualitative or quantitative data, and they have space between the bins. A histogram is like a bar chart, but can only be used for quantitative data. There should be no gaps between the bins unless a bin has no data in it or a value of 0. Line graphs connect points of data change over time, and pie charts represent the percentage of a whole. Lastly, it's important to remember that correlation does not equal causation. It is nearly impossible to prove causation. Statistics show that the number of murders increases at the same time that ice cream sales increase. Does that mean ice cream causes murder? No. As temperature increases, people become more easily aggravated and murder rates increase. Hotter temperatures also result in a higher number of ice cream sales. Separately, correlation does not equal causation.